Hello everyone. This lesson we're going to continue on power factor correction for three-phase circuit. So, an industrial building have two motors and some resistive heating. The supply is 600 volt three-phase supply. Motor 1 is 40 horsepower, 70% efficiency, 70% power factor at full load. Motor 2, 50 horsepower, 80% efficiency, 75 power factor at full load. Then we have a 20 kilowatt total resistive heating load. The question is going to ask you to calculate the power factor of the whole building with those loads. Then we're going to calculate the line current at this load. After that, we're going to calculate the capacitor's bank, the kVArs, to improve the power factor to 92%. And then we're going to calculate the new line current and the 92% power factor. So first, we're going to calculate each individual load. Motor 1, the power output is the horsepower rating times 746, give us 29.84 kilowatts. The power input on the electrical terminal will be power output divided by the percent efficiency, gonna be 42.63 kilowatts. Then the total VA gonna be power input over the power factor, 60.9 kVAs. Then we can calculate how many kVArs this motor 1 has. By using the formula VA squared, subtract P squared, take the square root, give us value 43.49 kVArs. That's the calculation for motor 1. Now we're going to calculate motor 2. Power output 50 horsepower times 746, 37.3 kilowatts. Power input is power output over the efficiency, going to be 46.63 kilowatts. VA 62.17 kVA, and the total kVArs going to be 41.12 kVArs. Now we can add total power together and the total VARs together, because the power is in the same direction as vector, VARs is in the same direction. Those motors have a lagging VARs, they are lagging at the 90 degree, so they are in the same direction. We can add the number together. Total power, we have two motors power plus the heater's power, give us total 109.26 kilowatts. Total VARs, we only have two motors have VARs, add those two VARs together, give us 84.61 kVArs. With those total power and the total VARs, here's our triangle with the power, VARs. We can calculate the total kVA of this place. Total kVA, VAR squared plus P squared, take square root, give us 138.19 kVA. That's the total kVA for the whole building. With the kVA, with the power, we can find out the power factor. Power over VA, give us 79% the power factor. We also can find out what's the original line current. Line current equal to kVA divided by root 3 divided by E line. So we calculate the line current 132.98 amps. That's the original line current. Now we're going to do power factor correction. When we do the power factor correction, the only thing we now change is the power, the true power in the circuit. Because the true power we never change. So when we know the new power factor, we can find the new kVA. Power over new power factor give us 109.26 divided by new power factor, 92%. We have 118.76 kVA. Now we can find new kVArs. VA squared, subtract P squared, take the square root, give us 46.54 kVars. This is the new kVars in the circuit, still lagging. This is the old kVars in the circuit. So the capacitor gonna providing a leading vars will be equal to the old kVars subtract the new kVar. So we did the calculation. Capacitor will have a 38.07 kVars leading. Look at this picture down here. Here the new, our power wasn't changing from the original, but the total circuit vars changed because we added the capacitive vars to reduce the lagging vars. Now we can calculate new line current, new kVA divided by √3, divided by line voltage. Put the number in, the new line current gonna be 114.28 amps. So here's the whole calculation for a power factor correction in three-phase circuit. We have a different kind of motor loads, we have a different kind of heating loads. And we add a capacitor in there, we can do the power factor correction. If you have any question, you can connect us online or send us an email.